Good morning. My name is Mackenzie Vedas, and for my lab experiment 8, determination of the molar mass and ionization constant of a weak monoprotic acid, I will be going through the setup and math. So to start, our setup is a titration. So in lab, we would use butterfly clamps, and that would give you the option to have 2 burettes side by side with 2 titration flasks. But for this lab, we're only doing it once, so that's why I went with this image. So you have your clamp stand that's holding your burette, and for our experiment we'll be using sodium hydroxide in the burette. So the first thing you want to do is make sure that your burette is clean, so there's no impurities that could possibly taint our analyte. So we're going to flush it a few times with sodium hydroxide, and when we finally fill it up, we want to make sure that there's no air bubbles right here at the tip. If there are, we're going to release a little bit of the sodium hydroxide, obviously not into the analyte, just kind of into a separate beaker and dump that out. So when that starts, that'll be the setup for the burette, and then for the titration flask, again, you want to make sure it's clean, and our analyte is going to be acetic acid. So what we're going to do is we're going to do drop by drop, adding into the analyte, and for one part of the experiment, after each drop, we're going to actually take the pH. So we'll be using a kind of like a pH meter. It's got an on-off switch, it's triangular, but we'll be doing that every time. And then we would normally do this in triplicate, but because we're just doing it once, this is our setup. So to continue on, we're going to find the molarity of acetic acid. So this is a little bit farther down in our calculations, so I did a little bit of labeling. So this we found earlier in the lab that we actually had 21 milliliters of NaOH go in, but because molarity is moles per liter, we have to change it to liters, so that's how we got the decimal. Then this is from our concentration of given, so that's why it's 0.1 mole over 1 liter. And then because this is a monoprotic reaction, it's 1-to-1. So that's why we have 1 mole of HA over 1 mole of NaOH. Now in this case, our HA was given. We know that's acetic acid, but we're going to continue to label it as HA. And then here we have the volume used. So again, we had to change, instead of having 30 liters, it's just 0.03. And then that will give us 0.07 moles per liter of acetic acid. Then we're going to find the molar mass of acetic acid in grams per mole. So again, this was a given value, 9 grams of acetic acid over 1 liter of solution. And we're going to multiply that by 1 liter of solution over 0.07 moles. Now we found this in our last calculation, and just to make note, you are able to flip these so the liters cancel out, and that will give us 128.57 grams per mole of acetic acid. Now in part C, we have to find the pKa value and the Ka value. So to find pKa, our given pH of a half neutralized solution was 4.72. So it's given that pH is equal to pKa, so that is 4.72, but if this wasn't given, this is only applicable if we have a monoprotic reaction. Otherwise, you would do kind of this longer math sequence, so we take the pH plus the log of the number. So that number is our placeholder over our acid, which is 1-to-1 because it's monoprotic, but this number could be different and that would affect our pKa value. But in this case, since it's just 1, the log of 1 is 0, and that gives us the 4.72. And then finally, we have to find Ka. So pH equals pKa, and Ka equals 10 to the negative pKa. So when you do Ka equals 10 to the negative 4.72, because we found that for pKa, it gives us the final value of 1.91 times 10 to the negative 5. Now, this is very small because the acetic acid is a very weak acid. If we had a very strong acid, the number would be very large. Thank you for watching and have a nice day.